Okay, so I'm going to start recording. Michael, you can tell me, are we stopping for a break at 11? Sorry, I meant to check this. Or Sophia, can you tell me? I'm assuming we,
Lunchtime.
but are we not having a break at 11?
We will have.
Yeah, just a short break, yeah?
It's
Yeah,
11
yeah.
now. It's
Sorry,
1 o'clock
sorry.
there. 1 o'clock there.
Sorry. Yes,
Yeah.
okay. So we're going to take a break at 12 o'clock, yes?
Yes.
No,
Okay. 5 minutes,
No.
10 minutes?
you're taking a break in 2 hours' time.
No, I'm going to take a break in 1 hour's time and then another one in 2 hours.
Okay.
Yeah, nobody wants to work for 2 hours. Not even teachers want to work for 2 hours. It's too much. So here we go. Right. I am going to do moles in session from 11 till 12. Then we're going to have a small break. And then at 12 till lunch, I will do the periodic table. It is a little bit about families of elements, and it is about periodic trends. Some teachers wanted to do some organic chemistry and some electrochemistry, but I did those last time we had a meeting. And so I will send you the presentations, but I'm not going to do them today. So I'm going to try to do moles today and periodic table. Moles is such a huge area that in my schools, I basically give one whole term to equations, moles, what we call quantitative measuring chemistry. And that includes practicals, obviously. So you might be heating up crystals to find the numbers of waters of crystallization, or you might be trying to reduce a metal oxide and weigh it and so on. But it is key to understanding chemistry at this level. After lunch, I plan to have a question and answer. So you can ask questions. I may not know the answer, but I will try to find the answer. And I will tell you a little bit about how I would structure the chemical course and what I would plan to do to bring out the greatest success in my students. My theory is this, and it is really simple. I teach the chemistry for the 4-year course. I teach all of the chemistry. We practice, we do some questions, we answer, we do many examples of balancing equations, writing formulas, getting used to the periodic table, and so on. But we do not revise except in small packets as we go along. So when we get to the end of a topic, we put together some revision notes, but we do not do test and test and test and test. In the last term or term and a half before the main examination, we revise. And at that point, I teach my students how to answer the questions. Because there are 2 skills here. One is understanding and knowing the chemistry. And number 2 is beating the examiner. I don't mean beating the examiner. I mean writing such a great answer that the examiner has to go, which is what we want. So that is what I do. I teach the chemistry and then I teach how to beat the exam. And this is a big deal because if you spend the whole Form 1, Form 2, Form 3, Form 4 doing chemistry, and then you get to the end near the examination and you have not looked at how to beat the examination, they will know the chemistry, but they will not be able to answer the questions. That is really important. We will look at that more later. So I have a presentation. I would like you to feel free that if I am going too fast or you do not understand, that you switch on your microphone and you say, hey, teacher Mark, a moment, please. Okay, and you explain to me what is wrong. Okay, so here we go. So what I'm going to do is I'm going to share my screen, and I have this presentation I said is going to be given to you after this. Let me just get it going. Okay, here it is. So I hope I'm not if you want to, you can minimize the cluster in the corner of your screen so you do not see me and all the other classes. You can press the little minimize button so it doesn't get in the way of the presentation. That's up to you. So here we go. So I'm going to start with something which is a teaching idea, and every so often I will throw in a small teaching idea which are more about how you help your class than about learning chemistry. So the first thing I would like to suggest is that in September you will be going to a class, and you may not know the class, and how you start with that class will fix how successful you are with that class. And what I try to do, therefore, and here are just some ideas, they are only some ideas I thought of last night, not a big deal. I think it's important to set rules for a class, but I think it's important to have a good relationship. And that means not being too fierce. I have watched some videos of some Kenyan teachers, and some of them are fantastic teachers. Fantastic. There is a teacher called Thaddeus Bakula, I think. I can't remember. Anyway, he's great. But I've also seen some who obviously believe that they are more important than their students. This is not true. So when you are setting rules, try to make them gentle. So we expect people to be polite. Oh, yes, obvious. We expect people to listen to each other. Obvious. We do not expect everybody to be silent all the time. We do not expect to write 25 different rules for being in a laboratory. This is not sensible. Know their names. The best way to stop the naughty kid, the bad kid, the misbehaving kid, is to know their name. Michael, behave. Sit down. Be quiet. I'm sorry, Michael. You need to get them to aspire. You need to get them to want and believe they can succeed. You need to find examples where they can succeed, and when they succeed, you feed back. Brilliant, fantastic, well done, asante, great. You get them to do the work. You get them to do the work because their success will be their success, not yours. Of course it will be yours, but you need to get them to do the work. In my lessons, when I started being a teacher, I talked all the time. I thought my job was to transmit the information. It was not. It was to make the students do the work. And I think if you are talking more than 20% of the time, unless it is a new topic, it is a mistake. Give them examples. Try to keep down the amount of your talking. Not, I can't do that today because I am trying to explain something, but try to talk less and get them to work more. Be kind. Be understanding. Remember what it was like when you did not understand something. I still, sometimes somebody brings me a question and I go, oh no, my brain has gone. Oh dear. I cover it. Yes, I'll just think. But I am also sometimes confused. Show your own enthusiasm. Show that you enjoy learning, that you want to be a good teacher, that you like their company. All these things are really important. Engage them and puzzle them. I have another thing which I will send you, a presentation, and it is called Thunks. Thunks. Thunks are little puzzles where you can project or just ask the question. And I'll give you an example. And it is a way to make their brains switch on. So here's an example. If I am in a red room and it is nighttime and I switch off the light, does the wall change color? I am in a colored room. I switch off the light. Does the color of the wall change? Here's another one. If I take a room and I fill it full of bricks, is it still a room? If I take a room and fill it full of bricks, is it still a room? Now, these sound stupid questions, but they are ways to make people start to think. Feedback clearly. If you feed back and you say, no, that's stupid. This is stupid. You are stupid. That will not help them. You have to be kind and you have to explain very clearly what it is that has gone wrong, and then find out with them what it is that they have misconceived, misunderstood, because that will help them understand how they can put it right. So feedback very clearly what has gone wrong. And don't forget, they are the very best class you will have just now. Maybe there's another one in 1 hour's time, which is better, but you are my best classes today. So I want to enjoy your company. I want us to do well because you are the best class. And finally, this is a basic technique. This is something that the British Army puts when they are teaching their teachers. This is what they tell them. They say, tell them what you are going to tell them it, and then tell them what you have told them. In other words, like today, I will teach you moles. Then we will do moles. And afterwards, I will confirm what we have done. It's a very simple idea, but it means introduce by setting out what you're going to do, then doing it, and then reflecting on it. Okay, here's moles. Again, you do not need to write any of this down because you will get a copy for you. It will be forwarded from Michael and Sophia and people like that. Great. So the stuff you have to know, or if they don't know, you have to get right, are these. So students have to be able to understand a formula. And by understand a formula, what I mean is, for instance, can they tell you how many oxygens there are in iron ethanediol 3? The answer is 12, obviously. But they must understand a formula. The second thing is they must be able to balance equations. Most people are quite good at balancing equations by the time they do moles. But if you pick up a new class and you haven't met them and they can't balance equations, balance them for them. Show them how to do it. And the last thing is they must understand what ratios mean. And I'll show you how we do that in just a moment. So in this equation above, which would be balanced with 2 aluminiums, 1 iron 3 oxide, 1 aluminium oxide, 2 ions. How many iron atoms would be produced if 6 Al2O3? Well, if there were 6 here in the Al2O3, then because it's 1 to 2, this must be 12. Okay, so formulas, equations, and ratios, they must understand before they do moles. If they do moles without that, they will not get very far. This is what I was talking about ratios. because people are frightened by the term mole because they think it is complicated, I do something really rather simple. I start with an equation like the burning of methane. Here's methane in oxygen producing carbon dioxide and water. Okay. I get them to turn that into words. So here's the equation. I want to turn it into words, and we are using words like molecule or atom or ion, in this case, all molecules. And so we get 1 molecule of CH4 reacts with 2 molecules and so on. Okay. Then I use multiples. So I say, okay, what's going to happen if I start with 20 or 5 or 100 or 1,000? Or can I start with half a molecule? No, I can't. And then because I have written this on the board, I take the board rubber and I get rid of the QL. So then suddenly I get 1 mole of CH4 reacts with 2 moles of O2 to make 1 mole of CO2 and 2 moles of H2O. And suddenly they are talking as I want them to. They have not made a connection between molecules and moles. They do not understand what a mole is, but I don't care because I'm going to teach them what a mole is. I just want them to talk, not about molecules, but about moles. Okay. So we know what a mole is. 600,000 million of anything. Huge number. 6.023 times 10 to the 23. Easy. It could be anything. If you had very, very large amount of hair, it could be mole of hair. It could be moles of, you could have a mole of grains of sand. You could have a mole of, I don't know, planets. You could have anything. A mole of jam. So we normally measure things in chemistry, and there are 3 ways that we measure things. We measure the mass. This is a top pan balance in my laboratory, a top pan balance with a beaker on, and I would press T to take away the mass of the beaker, then I would put the chemical in. Easy. We can work out the mass of a liquid, obviously. If it is a pure liquid, if I am working with, like, say, an alkanol or an alkanoic acid and it's pure, then I can weigh it. But if it's a solution, I can't. Well, there is no point. I can even weigh a gas. I have sometimes taken a balloon and weighed it empty, then filled it up and weighed it again. And the students are amazed that gas weighs something. Solutions, we need volume and concentration. Easy. There is always 2 quantities for solutions. And for gases, whether we are using a gas syringe or we are collecting the gas over water or upward displacement of air, or it doesn't matter. However we are collecting it, we measure the volume of a gas. Now, in the solutions, in the solids, we are normally talking about grams. In volume, in solutions, we are normally talking about cubic centimeters, and we have to be careful with that. Mils and cubic centimeters, most students think are different. They're not. Milliliters and cubic centimeters are the same, obviously. And in volumes of gases, we are normally talking about cubic centimeters or mils, the same. Now, that means we have to do something. Now, excuse me, I use colors a lot with my students. So I'm using green for masses, red for solutions, for concentration and volume, and black for gases, for volumes. And I use relationship triangles, and relationship triangles are useful because if they can remember this, they can convert between the 3. So I know that if I cover moles, it means that moles equals grams over the relative formula mass. Now I'm going to use RAM for a reason that you'll see in a minute. RAM, relative atomic mass, RMM, relative molecular mass. RFM, relative formula mass. It doesn't matter which one we're talking about, but I'm going to stick with RAM for a reason you will see in just a minute. So here we are. Here's the triangle. And the question is this rather easy or difficult to remember? Now, most of my students used to find it difficult until I asked them one year, about 20 years ago. I asked if any student could tell me an easy way to remember this. And one of them said yes. That student went on to Cambridge University to study computing. And I met him about 10 years ago, and he had just sold his company for £10 million to Microsoft. He was a very, very bright student, but what he came up with was very silly, but quite clever. Ah, Mathari are getting coffee. This is not fair. I want coffee. Excuse me, Mathari. Mathari, I need Sophia, I think. I need coffee too. Sophia, hello. Yeah, aha. Osharika, are you getting coffee? Well, I think you should, because Sophia seems to be getting coffee from Mathari. This is not fair. Anyway, sorry. So this is quite difficult to remember, but my student gave us a way to do it. And here it is. This is what he said. What? He said, I want to use this. I said, what are you talking about? And he said, I want to use this. Now, the English, well, the British version is different, but I think you may remember or recognize this as a mole rat. And he said, yes, I have a way to remember it. Look, I get the triangle and I put the mole rat here. And mole rats dig, and they dig with their teeth, and then they have their paws and they ram the earth underneath them, and the next one pushes it back and they push it out of the burrow. So they ram. Where do they ram? They ram under the ground. Here is some ground, here's a mole rat, and they ram. Oh, wait a minute. And I said, what are you talking about? And he said, you see, here's the triangle. And I remember it because moles ram underground. Now, this is a stupid way of remembering something, but students sometimes need a stupid way to remember something. You see, I have moles down here. I have ram here under G. G standing for ground. No, G is grams, obviously. But if I give them this triangle and I ask them to remember it, they have a problem. So I come up with this stupid way, and they remember moles ram underground, and then moles ram under G. And they may remember that. So moles ram underground. Try it with your own students. They will soon remember a really annoying, stupid picture like this. And then they will be able to do masses. So you cover the quantity you want, you get them to do many, many examples. Moles is grams over RAM or RFM or RMM, it does not matter. Grams will be moles times RAM, and so on. Simple. Solutions, well, this is the solutions triangle, and we normally say that the volume is going to be over 1,000 because it is normally in cubic centimeters, and it has to be in cubic decimeters. And I say, okay, how do we remember this? Well, if we were to pour a solution onto the ground, the moles must come up to the top. So in this triangle, solutions, if they do not come up to the top, if the mole is not at the top, then the mole would drown. So in the first one, moles are underground. In this one, the moles are at the top. And then your students will remember that we have concentration and volume at the bottom. So concentration equals moles over volume. Volume equals moles over concentration. Moles equals concentration times volume. Simple. Silly, but simple. Cover the quantity. Moles is concentration times volume. You have to reinforce that the volume has to be over 1,000. Concentration is the moles over the volume in cubic decimeters. The cubic centimeters over 1,000. Don't forget, you are going to get these slides. So if you want to just use them with your own students, just use them. I'm going to stop sharing for a moment. Okay. Okay. So what I want to know is this okay? Is this, or is this not okay so far? Is this useful? I'm not going to listen to Mathari. Mathari have got coffee. It's not good. Kisumu, is this okay, or is it too simple? Is this okay? Okay. Wamuini, is this okay, or is it too simple? Be honest, please. Okay. All right, fine. Ushirika, is it okay? Oh, no. Guy in the front is going to sleep. No, he's just checking his phone. That's okay. It's okay. He's just checking his phone. You have to have an eye for the student who is not in the class because they have their phone under the table. And they're just checking tonight's social engagement. Yes, you in the red t-shirt. Yes, it's you. You are the winner of I Have Done Wrong Today. Oh, yes. A quick round of applause for the teacher who's been caught with his phone. Sorry. I'm sorry. Never make fun of your students unless you are pretty sure that they are big men and they can take it. Thank you. Okay, so I'm going back to sharing. I'm going to finish off with the third triangle while Mathari sip their coffee. Okay, so the gas volumes one is very similar to the first one in that the moles are down at the bottom and the quantity which we are going to be told, like RAM, like RMM, like RFM, is down the bottom right. And it's 24,000 cubic centimeters. That is the volume, the molar volume for a gas. It's 24,000 at room temperature. Not today. Today is too cold. Today it's probably 23,500. But they only ask you to use 24,000 or 22,400, which is it at STP. So there it is, like the first triangle where it is grams over RAM. This is the volume over 24,000. This is the quantity you will be told. Okay, the question will always give you the molar volume. Here's a teaching idea. In my laboratory, I have a box. The box says question mark on it. It's a small box. And every so often I stop the lesson and I say, when I find people are getting bored, I stop and I have a game of 10 questions and the students have to ask 10 questions to find out what is in the box. Now, I don't actually have to put something like an elephant in the box, but I could write elephant on a piece of paper and put it in the box. They then have 10 or 20 questions, and it gets them working as a class because somebody will be going, I want to ask a question. And they get to work together as a class. And it just 5 minutes. It will not spoil their learning. It may make their learning better because they have been distracted. Their brains have unwound for a moment. They have stopped being stressed. They are thinking about something else. So what's in the box? Just an idea of something you can do. Sometimes we run out of time at the end of a lesson. Sorry, run out of material, of subject at the end of a lesson. What's in the box? Always have it ready for just a little something. Okay. So these are questions which you might want to have a go at yourself if you've got a calculator. But I tend to make them easy at the beginning and more difficult at the end. And you remember I said try to get your students to aspire. So I would set up 3 questions like this. How many moles in 4 grams of sodium hydroxide, 0.0055 of calcium carbonate, and a kilogram of water? The kilogram of water is the most difficult. I would call these bronze, silver, and gold. And the good thing is that it allows you to start with the easiest one or go straight to the most difficult. Now, the most difficult one is not difficult. These are very straightforward. But if we have a student who is struggling, who is not a good learner, then they might want to start here. But if we have somebody who doesn't really believe in themselves very much, but you think they are better, you can say, I think you can do A. Ignore A, don't do A. Go straight to B. And some people will automatically start going for the most difficult. If you say you've only got to do one. So some people will say, I will start with easy. Some people will say, no, I'm going straight to difficult. It lets them aspire. It lets them imagine that they can do them. I'll give you the answers. It will be 4 over 40. It will be 0.0055 over 100 because the RFM of calcium carbonate is 40 and 12 and 48. It's my favorite chemical because it is 100 as its RFM. And for the kilogram, we will have to turn it into grams. So it's 1,000 over 18. So the answers are, for the sodium hydroxide, it's 0.1. For the calcium carbonate, it's 5.6 times 10 to the minus 5. You will get all these answers and the questions, so you can use them with your own students if you wish. A kilogram of water, 1,000 over 18, 55.56. Okay, simple. But they're nice. They are nice to give people the chance to just go, okay, I pick the one I want to do, and on I go. I don't believe it. I've just noticed that Mathari have something to eat as well, not just coffee. This is unbelievable. This is a conference. Obviously, Mathari are very rich. Okay. So here are 2 questions for the volumes and concentrations, for the solutions one. And the first one is very simple because you are given the volume and the concentration. But again, the second one is much more complicated because if I dissolve 3.65 grams of HCl in 250 of water, wait a minute, I haven't got a concentration yet. So in the second one, I am encouraging people to realize that they would have to use 2 of the triangles. So in the first one, 25 cubic centimeters of 0.5. I remember the triangle. The triangle says moles is concentration, that's the 0.5, times the volume over 1,000, 25 over 1,000, there we are. Second triangle, moles is concentration times volume over 1,000, so 0.5 times 25 over 1,000, 0.0125. Nice and straightforward. The second one is more difficult. We know the second triangle, we need the concentration. Well, the concentration is in moles per the particular number of cubic decimeters, but we're not given that. So we have to use the mass, which is 3.65, and the RFM or RMM of HCl, which is 36.5. So the moles is 3.65 over 36.5, which is 0.1, and the volume is still 250, but 250 over 1,000 is 0.25. So the concentration is 0.1 over 0.25, which is 0.4. Now, if we look at the question, the 2 questions look very similar because they're just written. And unless you are being intelligent, the students will not realize that the second one is much more complicated. But this is why it is quite good to construct some questions which are really easy, So you can give somebody a pat on the back. You can say, well done, that is very good. You have done A, well done. And some people are going to, so you might have not very good students doing well on number 1, and very intelligent students getting stuck on number 2. Well, that is good, because now everybody is busy in the classroom. The less intelligent student is struggling with number 1, but is going to do it. And number 2 is for the cleverer student, who is going to have to work out that they need to work out using the maths first. Okay, so if you want to use, I mean, there's no need to use any of this, but you will have this and you will be able to use it to construct your own way to show them how to do it. That's why I'm doing this. And here's volumes of gases. So a mole of a gas is 24 cubic decimeters at room temperature pressure, 22.4 at 0, still 1 atmosphere. So at the top, the volume can be in cubic centimeters, in which case it's 24,000 down here, or cubic decimeters, 24 cubic decimeters. Most of the KCSE examination questions use STP and 22.4, not 24. So here are some questions. Again, they make more and more difficult. They are more and more difficult. The first one is really easy. How many moles of nitrogen? 2.4 cubic decimeters. If I can remember the triangle, moles is at the bottom left. The volume is at the top. That's the 2.4 cubic decimeters. At the bottom right is 24 cubic decimeters. So moles equals 2.4 over 24. That is success for not very good students. That's great. You can give them one of the biscuits which Mathari has. You can go, well done, student. Have a biscuit. The second one is more difficult because we would have to work out how many cubic decimeters there are in 1 cubic meter. Much more difficult. In the third one, 6 grams of hydrogen. What volume? Wait a minute. 6 grams? That's not a volume. So I have to use the first triangle to turn grams into moles, and then I can find the volume. And in the last one, it's working out a molar mass, starting with the volume triangle first. I will let you have a go at those sometime, but not probably now. I'll just show you the answers. So in the first one, it's simply 2.4 over 24. In the second one, a cubic meter is 1,000 cubic decimeters. So in 1,000 cubic decimeters, I have 1,000 over 24, 41.67. 6 grams of hydrogen, I have to work out the moles of that first. So 6 grams over hydrogen, remember it's H2, so it's 6 over 2, which is 3. So I've got 3 moles. I want the volume. The volume is moles times 24. 3 times 24, 72. In the last one, 2.2 grams of X, volume of 1.2. What's its molar mass? Well, I work out the moles first using the volume triangle. So I know that it's 0.05 moles, has a mass of 2.2. Now I go back to the first triangle. RMM is grams over moles. 2.2 over 0.5, 44. It's probably carbon dioxide. Use some everyday examples. I have been looking and I see that in KCSE questions, over the last 2 years, they have changed. They all used to be lots of writing and they would be very chemical. And now they are making them more commonplace. So if you can get imaginative about your questions, this is good. There are many, many questions you can get from textbooks. Excellent. Use them. They are really good. But also try to make up your own. Here I have a couple which I have got, which I just made up. So here they are. Use some everyday examples. Here's one. Ask your student to look up. Here is a standard, probably steel roofing sheet. How many moles of iron in it? They'll go, what? You could ask them to how many particles there are in it. But if you just tell them, okay, a standard steel roofing sheet weighs 6.5 kilograms, then it's just a different way of thinking about things. It's making them work out something commonplace. How many moles of sucrose in 100 grams of sugarcane? I have a piece of sugarcane, 100 grams. How many moles of sucrose? Well, in every 100 grams of sugarcane, you get about 12 grams of sugar. It's slightly over 10%. That's all. Most of it is just pith, that horrible stuff that gets stuck in your teeth or cut your lip. This stuff. So we can work it out. Only it makes it a little bit more interesting. If you have a 25-meter saltwater swimming pool, how many moles of salt? Well, you could then spend some time working out the volume, but I will tell you here. The volume is 1,700 cubic meters. And it contains 5,400 kilograms of salt. So you can work it out. You can give them parts of this. You could say, I have a swimming pool. Its volume is this. It contains this much salt. How many moles is that? So you are just turning it into something a bit more real life. Okay. So then we move on to proper examination questions. So when you have in your 1-hour lesson, you need to get to the point where you can ask some proper examination questions. I'm going to let you have a look at this for a few minutes. I want you to talk to your neighbor about what you would do. I will give you the answers. If you want to have a go at it, do. But just, this is a question you have probably not seen. It is a real KCSE examination question from about 2019. I just copied it out. Just have a look at it. Just agree with your neighbor what you would do, where the problems would be. Is it easy? Is it difficult? It is probably quite easy for you, but your student may find it very difficult. So have a few moments just to think about and talk with your neighbor about what you would do in this question. I will drink some water. Have a conversation. Talk with somebody. You must talk. You must get your students to talk. I like Kisumu. Kisumu, very, very good teamwork. I really like that. That is excellent. Well done. Really, seriously, very, very good. Teacher Wycliffe at Wemwini just knows all the answers anyway. Headmaster Yestin obviously knows all the answers anyway.
I like the bit at the start. I'm going to actually ask you about inspiring teachers, inspiring pupils. No, about your soft lessons.
Yeah. Okay.
Stuff.
I love them.
Go on.
Well, it's just I think it's really important that you make them feel that it's not exactly a family, but you're sort of like all struggling to do exactly the same thing.
Yes.
We're only going to be letting down our team, our family, if we argue or if we talk across each other, all that sort of thing. So we don't need lots of rules because we're just going to be doing it properly.
Yes. Gentle rules. I liked it.
It's easy, isn't it? It's all obvious.
I'm going to pick your brain over the weekend, or just for you to think about. But I want your top 5 clues for teachers to inspire pupils.
To inspire. Okay.
Yes.
Okay.
Yeah. Sorry, I'll shut up. I'll shut up and go away.
No, it's all right. Kibera, I like it. The guy with the red shirt who was on his phone earlier is now working with a calculator with his neighbor. That is excellent. Well done. You see, you gently remind somebody of what they should be doing, and suddenly they become the top student. It's excellent. Kisumu, very, very good. Well done. Very, very good. I like that people are trying to do this. It's very good. I think some of you probably find this very easy, but some of you not so easy. And it is very good to have to struggle a little bit sometimes. For us to have to struggle, to remember what it is like. I expect that Fatma knows the answer already. I'm sure Wycliffe knows the answer already. I'm sure Oris knows the answer already. I'm sure that many of you already know all the answers. So because we are running out of time a little bit, because I want to give you a break, I'm going to give you the answers and you can just look at it and go, yes, of course. So here we go. It will show you how it goes. So here we go. So the first question is, which chemical is in excess? So if we look at the equation from the first triangle, the zinc is 1.96 grams. So we use the first triangle and it's 1.96 over 55.4. So that gives us 0.0299, which is around about 0.03. The hydrochloric acid, this is the second triangle, the solution triangle. Moles is concentration times volume. So it's 0.2 times 100 over 1,000, which gives me 0.02. So 0.03, 0.02, and that means the zinc is in excess. Now that means that not all the zinc will be used up. That means that the hydrochloric acid will determine, in the question it said how much hydrogen is made. Let's go back to the question. Here, in part B, the total volume of hydrogen was liberated, okay? So that now depends on the amount of hydrochloric acid because the zinc will not all be reacted. So that is worth 2 marks. If you got that, well done. So then we move on, and now we say, okay, this is going to be the third triangle for the volume of hydrogen, but it says, here's my equation, and I know that if we look at the equation, the ratio of hydrochloric acid is 2 to 1. So if I had 0.02 here, that will make 0.01 here. So the answer will be 0.01 times 22.4, because it said STP, so it's 0.224. So that's 2 marks. Now, that's quite a hard question, and that might take even really very good students like yourselves, but also like good students, really quite a long time. This is where you are getting them to do the work. I'm not going to go through this. We're just going to, here's just another example. It's talking about zinc sulfate, which is used in helping people be well, giving people minerals, and it is hydrated zinc sulfate. And in this, you are trying to work out the number of moles of water and therefore the ratio. And there's all the answers for there. There is a bit about using Avogadro's number. And if you get this later, you press this, it will explain. I think you'll be able to do this yourself. All you have to do is to remember. And I'm not going to listen to myself. So there we are. This is talking about using Avogadro's number, the actual number. In other words, finding out the number of particles. This is where knowing the formula is really important. There's the answers. Here's time for a teaching idea. We're nearly at time where we're going to stop. Getting students to aspire. I mentioned bronze, silver, and gold. And if you set up questions as bronze, silver, and gold, then they will find it that they want to do gold. Now, empirical formulas. And I'm just going to go through empirical formulas, but this is something that I often start a lesson with something like this. Excuse me. So I tell the students, today we're going to study and practice empirical formulas, whatever it is. And then I say, here it is. And I tell them, you will be able to do this. I never say it's going to be difficult. I never say that, because otherwise they believe they cannot do it. If I say, you will be able to do this, then they will worry when they can't, but we can show them how to do it, get them to believe. And I'm not going to go through all of this, but I'm going to give you my way of doing empirical formula, and then we will stop for a small break. So you know that the empirical formula is the simplest, and it is important to start with a relatively complicated formula like glucose or fructose also. C6H12O6, and get them to simplify it, and it becomes CH2O, and its empirical formula. That is the empirical formula. Then give them some examples. Realize that some of them do not change because you cannot simplify this because there is only one copper sulfate, but this becomes HO, and so on. Give them examples, give them time, let them do it. But I use this. I'm Dr. Empirical. And I'm not actually talking about this very good looking doctor. I'm talking about IMDR. I try to get them to remember IMDR. I'm doctor, I'm doctor, I'm going to be a doctor, I'm doctor, because this is what I do. I go, okay, here's an example, 70% iron, 30% oxygen. I'm going to construct something using IMDR. Okay, IMDR stands for information, moles, divide, ratio. Now, I'm sure you all do something like this, but I find it useful to have something like the silly moles at the beginning, something like IMDR to help them remember what they've got to do. So in this case, the information is iron, RFM56, 70%, and so on. I work out the moles, 70. I can assume percentages are masses, because if I had 100 grams, that would be 70 grams, and so on. 70 over 56, and so on. I've got my moles. Then I divide through by the smallest. The smallest one is 1.25, 1.875 larger. So I get 1 and 1.5, 1.5, and therefore the ratio is 2 to 3, because we can't have a half an oxygen, and therefore it's Fe2O3. Some people construct this horizontally. Here's another example, and there it is constructed horizontally. Information in the first columns, moles, divide through by the smallest ratio. So here we are, 37.2. 37.2 divided by 12 is the moles of carbon here. 3.1. Divide through, the smallest number was the chlorine, which was 1.55. 3.1 divided by 1.55 is 2. I get the ratio, and therefore I get out C2H5Cl. Now, if you want, after the small break, we will go through this, but I'm not expecting to. Here are some which I then give. Here we are: bronze, silver, and gold. Here's a bronze one, which if you're feeling confident, you would go, no, I'm not going to do that one. If you're feeling underconfident, you might use this one, and then you might use silver, or you might go straight to gold. And if you go straight to gold, you might need more help, but get your students happy to put up their hand and say, I need help, and then you will come to them. Okay, there are the answers, and time for another teaching idea I will come to after this. But just now, we're going to take a small break. Okay, because I think you need to get up and move around. I think I need to. I need to have some water, and so we'll come back in. How long do you want, Michael, Sophia?
10 minutes is okay.
10 minutes. 10 minutes it is. The time is going. Get up, walk around, enjoy yourself, talk to somebody you haven't seen for a long time. Go and run around outside. If you are in Mathari, you have had too much coffee, so find the restroom.